So differentiating inverse trigonometric functions. Okay, so just a reminder, okay, so a quick reminder is that when what we call the arc sine of x, okay, so if the arc sine of x equals y, this means that x is equal to the sine of y. That's what it means. Okay, it's what you called in high school sine minus 1, right? When you had the sine and you wanted to find the angle. Okay, so the arc sine of a little decimal will give you an angle. Y is an angle. Okay, so for example, here, just for you to visualize with numbers, if I'm asking you for the arc sine of 0.5, well, you're asking yourself the sine of which angle give me 0.5. What is it? You know it?
45.
No, not 45. What angle has
30.
0.5?
30.
Okay, 30 degrees, but of course now we're in calculus, so we don't use degrees anymore. Although it's not wrong, but we are used to writing in radians, so pi over 6, okay, which is 30 degrees. So the arc sine of 0.5 is pi over 6. Good. Okay. And same thing for the arc cosine, arc tangent, arc cosecant, same principle. Okay, I'm not going to write it for everything, but that's the idea. And now I want to derive this function. Okay, so let me write them down. I'm going to write all the formulas here. So if f of x, and then we're going to prove them. So if f of x is equal to the arc sine of x, then f prime of x equals. Then if f of x is equal to the arc tan of x, then f prime of x equals. And then if f of x is the arc secant, then f prime of x equals. Let's do these three first. And then on this side, I'm going to do the arc cosine, arc cotangent, arc cosecant. Okay. So the derivative of the arc sine, if you don't know it, you could never guess it. Okay. So it's 1 over the square root of 1 minus x2. Okay. The arctangent, I'm missing a c here. The derivative of arctangent is 1 over 1 plus x2. And the derivative of arc secant is 1 over x times the square root of x2 minus 1. Okay, so it's very, very, very important for calculus 2. This. Okay, this we're going to use this a lot in calculus 2. Okay, so let me do while I'm here on the next side here on the other side. I will do cosine, cosecant, cotangent, and cosecant. So let's say f of x is arc cosine of x, then f prime equals. Then if f of x is arc cotan of x, then f prime equals. And if f of x is arc cosecant, then what's f prime? Okay, so of course we're going to have to prove all of these. Okay, so it's the exact same thing. The arc cos is the exact same as the arc sine, same thing except with a minus. Okay, so same thing as the arc sine, 1 minus x2, but there's a minus in front. Same thing, arc cotan is the same thing as this, so 1 over 1 plus x2, but with a minus, and this also 1 over x root x2 minus 1 with a minus. Okay, so this you have to know by heart. Okay, it's very, very important, very useful, especially for Cal 2. You will see when you will do some substitutions. Okay, so let's start to prove. So first proof. So there's 6 proofs here. So first of all, if f of x is equal to the arc sine of x, let's prove that f prime of x is equal to 1 over the square root of 1 minus x2. Okay. So move up here, so I have my space. Okay. So look at what I'm going to do. I'm going to call this y. So arc sine of x, I'm going to call this y. Okay, so of course I'm looking for y prime, right? So this means that according to what I wrote on top, right, just back up here 2 seconds. So this means that x is equal to the sine of y. That's what it means. Okay, so I'm going to write here. So this means that x is equal to sine of y. Questions? Okay. So now I'm going to derive both sides implicitly. So the derivative of x is 1 equals, and the derivative of sine y is what? Can you tell me? You should know this by now. What is it?
Cos y.
Cos of y times
Y prime.
y prime. Okay, don't forget, y is a function of x. Good? Okay, and so that means that y prime is equal to 1 divided by cos x. Sorry, 1 divided by cos y, sorry. Any questions? Okay. So now I'm going to do something. I'm going to do something here. I'm going to draw a little triangle. A right triangle. Okay. And I'm going to represent this situation here, where sine y equals to x. Okay, sine y is equal to x. What does that mean? That means in this triangle, if this angle here is y, well, the sine of this angle has to be x, or x over 1. Okay, and the sine, as you know, is opposite over hypotenuse. So in this triangle, if I want to represent the situation, this triangle would have an x here and a 1 here. Do you understand this?
Could
Okay.
you repeat that?
Yeah. Yes, yes.
Could you repeat that?
What?
Could you repeat that?
Yeah, I repeat that. Okay. So if arc sine of x is y, this means that the sine of y is x. Good, that's true. This you agree. Now, if the sine of y is x, it means that the sine of y is equal to x over 1, right? That's what it means. And the sine, we know it's always opposite over hypotenuse. So if I draw a right triangle here with an angle y here, then this opposite over the hypotenuse should be x over 1. Or 2x over 2, or 10x over 10. Who cares? X over 1. The ratio between this and this has to be x. Is that okay?
Yeah.
Okay. So now I could find this side here by using Pythagoras. Okay. So this side we know is the square root of 1 minus x2. Is that okay?
Yeah.
Okay, good. So from here, well, I need to find the cosine of y. I need the cosine of y, but the cos of y is always the adjacent over the hypotenuse. Okay, I'm going to write this. Adjacent over hypotenuse, which is square root of 1 minus x2 over 1. Is that okay?
Could you lower the page, please?
Oh, sorry. Sorry. Okay, again, I will repeat that you couldn't see. So thanks to Pythagoras theorem, I found that this side is 1 minus x2 square root. And then I'm looking here for the cos of y. And the cos of y is adjacent over hypotenuse. So adjacent over hypotenuse will be root of 1 minus x2 over 1. So that here should be root of 1 minus x2. And so I just showed that y prime is 1 over the cos of y, which is 1 over root of 1 minus x2. And that's it. I proved it.
I have a question.
Of course, yeah, go ahead.
It's about y is 1 cos y times y prime.
Y is what? I'm sorry?
You see the second arrow? It says 1 equals,
Yeah. Cos
Y.
y times y prime, yeah. Why is there y prime here?
no, y, it equals that.
Why does 1 equals to that?
Yes.
Because I did the derivative of both sides.
Oh, okay.
Derivative of x is 1, derivative of this is that. Yeah?
Okay, I get it now. Yes.
Oh, okay. Okay, any questions? Okay, so this little exercise with this triangle that I just did here, you're going to do this a lot in calculus 2. Okay, so might as well get used to doing it now, and doing these proofs here is it's the best exercise for you to do this. Okay, so do you think you could try the arc cos on your own? You think you could try it?
Yes.
Okay, so go ahead, try it. All right, so let's prove the second one. That if f of x is equal to the arctan of x, then f prime will be 1 over 1 plus x2. Okay, that's what I need to show. So again, so the same. If arctan of x is equal to y, this means that x is equal to the tangent of y. And so if I do the derivative of both sides, I will get 1 equals to secant squared of y. Is that okay?
Yes.
You sure?
You said we were doing cos.
Oh yeah, I did cos. Sorry. Okay, I'll do arctan first, and I'll do cos. Sorry.
It's fine.
Okay, so is this okay?
Times y prime.
Okay, thank you. Times y prime. Okay. So it wasn't okay, but if it's okay, it wasn't okay. So then I will divide. So y prime is equal to 1 over secant squared of y. And you remember the identity? There's an identity that says that secant squared of x is 1 plus tan squared x. You remember this? Okay, there's an identity here. And so here, that would mean that y prime is 1 over the secant squared is 1 plus tangent squared. Okay, and tangent y is equal to x, and so this will be 1 over 1 plus tangent squared, so x squared. That's it, done. Okay, it's not difficult. Okay, so let's do arcsecant first, and then we'll do all the cosine, cotan, cosecant. Okay, so let's do arcsecant first. So proof that if f of x is equal to the arc secant of x, then f prime is 1 over x times root of x2 minus 1. Let's see if we could get to this. So same idea, arc secant of x is equal to y, therefore x is equal to the secant of y. And then I will do the derivative of this. 1 is equal to secant tangent times y prime. That's okay. Okay, the derivative of secant is secant tangent and times, of course, the y, so y prime. And so y prime will be 1 over secant tangent. Any questions? Okay, so let's do our triangle here. Okay, I could do it differently with the with the identity here, but let's do it with the triangle. So I'm just going to go here 2 seconds, and I'm going to notice that secant is 1 over cos. So this means that x is 1 over cos y, and so this means that the cos of y is 1 over x. Good. And so I could draw my triangle again. 90 degrees, y, and can you tell me where I'm going to place the x and the 1 here? Can you tell me? Cos of y is 1 over x. So how should I label my triangle?
You put 1 over x on the bottom, like the right,
On the what?
like not opposite to y, adjacent to y.
What do I put here?
1 over x.
Okay, so I'm just going to put 1.
Okay.
I'm going to put x here.
Okay.
Okay, because now I have the cosine is adjacent over hypotenuse. I could do what you say, put 1 over x here and 1 here. You could. You're right. But I don't want fractions, so adjacent over hypotenuse. Okay. And so what is this here? This will be, according to Pythagoras theorem, it's x2 minus 1 square root. That's the side. We okay? Okay, that's it. So from here, I'm going to need the tangent. So the tangent is always opposite over adjacent. And so that is square root of x2 minus 1 over 1. This is what the tangent of y is, which I'm going to replace here now. Secant y, of course, is x. And tangent y, I just showed that it's square root of x2 minus 1, done. Okay, any questions? Okay, so let's go 3 more to prove now. Okay, so let's do arc cosine now. So prove that if f of x is equal to arc cos of x, then f prime is same thing as the arc sine but with a negative. Okay, so let's go again. R cos x equals y. This means that x is equal to the cos of y. Okay, so by the way, any of these could be asked to you on the midterm, by the way, right? I could ask you to prove this for sure. So you should know how to do this. So let's do the derivative of both sides. So this is 1, and the derivative of cos is negative sine y times y prime. And so y prime is negative 1 over sine y. So obviously, you see where the minus is from. Okay, so same principle. Let's do the triangle. Cos of y is x over 1. So I will do my triangle right here. The angle is y, 90 degrees, and I see that the cosine is x over 1. So cosine is adjacent over hypotenuse. So this is x over 1, adjacent over hypotenuse, adjacent over hypotenuse is equal to the cos of y. And this, of course, Pythagoras, square root 1 minus x2. And I'm looking for the sine. So sine is opposite over hypotenuse. So opposite over hypotenuse. That's it. So I could replace sine y by this, and I'm done. Okay, that's what I wanted to prove. Okay, so try not to learn these proofs by heart and try to understand it, because I might on the test just give you a little variation and throw you off. If you learn by heart, a little variation throws you off. Okay, it's better you understand it. Okay, proof. The other one is if f of x is arc cotangent, then f prime will be negative 1 over 1 plus x2. Okay, am I going a bit too fast? Okay. So again, r cotangent equals y means that x is equal to cotangent of y. Derivative 1 equals, the derivative of cotangent is negative cosecant squared y times y prime. And so y prime is negative 1 over cosecant squared y. Okay, and just a reminder that the cosecant squared of x is 1 plus the cotangent squared of x. So I'm going to use the formula right here, the identity. So y prime is negative 1 over 1 plus cotangent squared y. So I'm going to move up a bit. And so y prime is equal to negative 1 over, so cotangent is x. So 1 plus x2, the negative here. Okay. So one more, and then we'll do some examples. Okay, so let's go. Last one, arc cosecant, yeah. So proof. So f of x is equal to r cosecant x. Then let's prove that f prime is equal to -1 over x root of x2 minus 1. So r cosecant of x is equal to y. It means that x is equal to the cosecant of y. And if I derive both sides, I get 1 equals the derivative of cosecant is negative cosecant cotangent times y prime. Okay, and therefore, if I isolate y prime, I get y prime is -1 over cosecant y cotangent y. Okay, any questions so far? Okay, so just a quick reminder here that cosecant is 1 over sine. So x is equal to 1 over sine of y, which means that if I isolate sine y, I will get 1 over x. And so I could do my triangle. Angle y. So sine is opposite of hypotenuse. So opposite over hypotenuse. Pythagoras here. X2 minus 1 square root. Okay, let's go back here. Cosecant y, that's x, so that's okay, we're good. Now cotangent, what is cotangent? The cotangent is the adjacent over the opposite. And so that is root of x2 minus 1 over 1. That's it. I replace everything here and I'm done. So y prime is negative 1 over x times cotangent of y, which is root of x2 minus 1, and I'm done. That's it. We proved all 6.
Sir,
Yep.
could you please repeat how do you know where to put the x and y for the right triangle?
Here.
Yes, please.
Okay, it comes from here. This step you understand?
Yeah, no, could you repeat it, please?
This also?
Yes.
Okay, so this you okay, right? From here to here you okay?
Yes.
Okay, then from here to here you okay? Cosecant is 1 over sine.
Oh, then you just, oh, okay, I understand that, okay.
Okay,
Yes.
that's it. So now at this point, we know that the sine is the opposite over the hypotenuse. So the sine of y, so in the opposite I'm going to put 1, and in the hypotenuse I'm going to put x. That way the sine will be 1 over x. Is that okay?
But what
Yes?
the hypotenuse is always 1. Why do we can't just choose where to put the 1 and where to put?
As you could put whatever you want, as long as this over this is 1 over x. You could put 2 and 2x if you want, because the ratio has to be 1 over x. That's what the sine is.
Okay, I get it.
Okay, so why are you going to complicate your life? Put 1 and x, that's it. Okay, or you could put, like somebody else asked before, 1 over x here and 1 here. You could also, it works. Just who wants fractions? I don't like fractions. Okay, so I don't know who has a question before. I think Zainab.
Yes.
Okay, so is this okay? How to set out the triangle or not?
Yeah, yeah.
Okay, and then I'm looking for the cotangent of y. Now the cotangent, I know that is the adjacent over the opposite. That's it. So adjacent is this, thanks to Pythagoras, over opposite, which is 1. That's it.
Okay, thank you.
Okay, good. So let's do a few examples before I show you logarithmic differentiation, which is not that difficult. Okay, let's go on. Let's move on. So example, again, find f prime of x. Okay, so first, let's say f of x is equal to the arctangent of root x. Okay, so that's not too complicated. The derivative of arctangent is, we just showed 1 over 1 plus whatever's inside squared times, of course, the derivative of what's inside. Right? Chain rule always applies. You get it? So it's 1 over 1 plus x times the derivative of root x is, we know by now, it's 1 over 2 x. And that's my answer. Two. F of x, let's say, is 3 to the power of arc sine of x. Can you tell me what it's going to be? Okay, so the derivative of a power something stays 3 to the power of arc sine of x times ln 3 times the derivative of the exponent. Okay, so almost done. 3 to the power of arc sine x times ln 3 times 1 over square root 1 minus x2. Any questions?
Sure.
Yep.
Could you go back to the first one, the first example, how you go between the first and the second step?
On the first example?
Yep.
On this one? How
Yeah.
do I go from this to here?
Yeah.
Well, this, the left part I just did square root power 2 is just x. Right?
Yeah.
And it should be absolute value of x, really. Okay, it should be the absolute value of x. Square root of x2 is the absolute value of x. But since the question already came as an absolute value of square root of x, so I'm assuming that x is already positive. So I don't need to put an absolute value. Okay, but forget this for now. Now, the square root, the derivative of square root, this is x to the half. So we've done this, power rule. You know how to do this. The derivative of this is just that. You know how? From here to here?
Yeah, now I understand.
Okay. Would you like another one?
Yes, please.
Okay, let's do another one. So number 3. So let's say f of x is equal to x cubed times arc secant of e power x. So of course we do the product rule because it's a multiplication. So it's x cubed prime times the arc secant of e to the x plus x cubed times the arc secant of e to the x prime. So two derivatives now to find. X cubed, that's very easy. It's just 3x2 times the arc secant of e to the x plus x cubed. And the arc secant, now we know the derivative of this is 1 over whatever's inside times the square root of whatever's inside squared minus 1 time, of course, the derivative of the inside, right? But chain rule is still effective. And that's it. The rest is just maybe simplifying this and doing this derivative, which of course it's itself. So 3x2 times arc secant of e to the x plus x cubed times derivative of e to the x is e to the x over e to the x square root of e to the 2x minus 1. And of course, this can cancel. And that's going to be your answer. Okay, let me just write it nicely. 3x2 arc secant e to the x plus x cubed over root e to the 2x minus 1. Okay, any questions? Okay, we're almost done. The last thing I want to show you is logarithmic differentiation. So I'm going to give you practice on this. Okay, so we have about a week and a half before the exam. So I'm going to give you practice on this. Okay, I'll try to prepare a review sheet. I don't know if I'll have time, but I'll do my best. So let me show you logarithmic differentiation. I'm just going to show you this through examples because you'll see that there's not much to say. Okay, so number 4. So look at this question. So find y prime, okay, or f prime, y prime. Let's say y is x to the power of sine x. Okay, so now we have a problem because we have an x on the base and we have the x and the exponent. So I don't know whether to use the power rule or whether to use an exponential. I'm stuck here. Okay, so what I'm going to do, so I will put a ln on each side first. Okay, so I'm going to write y equals x to the power of sine y, and I'm going to put a ln on each side. I'm taking the ln on each side. Okay, and that tells me that the ln of y, and here, you know, with the properties of lns, I could bring down the sign in front. Sine x, sine x, ln x. Is this okay? So I didn't do derivative yet. I just applied ln on each side and brought down what I could, the exponent. And now I'm going to the derivative on both sides. So the derivative of ln y is what? It's 1 over y times y prime equals, and the derivative here, of course, I have to do the product rule. So it's the derivative of sine x times ln x plus sine x times the derivative of ln x. So let me put like this, prime is prime. Okay, you're with me so far? I'm not getting any feedback, so I'm assuming you're okay. Okay, if you have questions, I hope you're going to tell me. Okay. So let's do the derivative here. So 1 over y times y prime equals derivative of sine x is cos x ln x plus sine x times derivative of ln x, which is 1 over x. And now I could isolate y prime. So y prime is equal to y times all this. Cos x ln x plus sine x over x. And then I replace the y back by what it was. And so y prime is x to the power of sine x times cos x ln x plus sine x over x. That's it. Okay, so this is called, when you put the ln on each side and then derive, this is called logarithmic differentiation.
So we only use logarithmic differentiation when it's x to the power of like a function?
Okay, that's one of the cases. For sure, when you have x, like a function of x to the power of a function of x, for sure you have no choice. Okay, but there's another case where it's not mandatory. Here you have no choice, but there's another case where it's not mandatory, but it's very useful. And I'm going to show you in a minute. Let me just give you one more example for you to try and get a feel for this. Okay.
Okay, thank you.
Okay, so let's go number 5. So technically, we're done the material for the exam. Let me just do 2 or 3 more examples to make sure that it's clear, and then I can answer your questions if you have. Okay, so number 5. So let's say y equals to let's say 3x plus 1 to the power of tangent x. Okay, so find y prime. So let's go. Y equals to, so 3x plus 1 to the power of the tangent of x. And so I'm going to put the ln on each side. So this says that ln of y is equal to, bring the tangent in front, tan x times ln of 3x plus 1. And then you derive each side. 1 over y times y prime equals 2, so tangent x times ln 3x plus 1, so tangent prime, plus tan x ln 3x plus 1 prime. Okay, so y prime, so I'm going to send the y up here right away, y times, and the derivative of this. So tangent becomes secant squared ln 3x plus 1 plus tangent x times the derivative of ln of 3x plus 1 is 1 over 3x plus 1, right?
Times 3.
Thank you. Okay, times 3. Okay, don't forget the times 3. Okay, I forgot it again on purpose. Okay, just to make sure that you're aware there's a times 3 here, which comes from the derivative of 3x plus 1. Okay, good. Okay, that's it. So my last step is just to replace the y back by what it was at the beginning. And so y prime is y, which is 3x plus 1 power tangent of x times this whole big expression, secant squared x ln 3x plus 1 plus 3 times tangent x over 3x plus 1, and this is my answer. Any questions? Okay, so that's a case where you pretty much have no choice but to use the logarithmic differentiation. Let me show you a case now where you have a choice, but it's very useful to use it. So let's say y is equal to, let's say, sine the 5 of x times x squared plus 1 power 9 divided by e to the power of x2. Okay, so this, I mean, you could do the regular derivative using a quotient rule and the top product rule and then a chain rule. It's kind of long and messy. Or you could also do ln and ln here. Okay, so again, find y prime. Okay, so y is equal to sine to the 5x times x2 plus 1 power 9 over e power x2. So again, I'm going to put ln and ln on each side, and I'm going to rely on the properties of logs to simplify my expression for me. Okay, so ln y equals, so the ln of the multiplication becomes the sum of the logs. So it's ln of sine 5x plus ln of x2 plus 1 power 9, and then we divide, you get minus ln of e to the x2. Okay, this we know. Okay, properties of logs. And so ln y is equal to, so the exponent you could bring in front. So 5 times ln of sine x plus 9 times ln of x2 plus 1 and minus x2 times ln of e, which of course is 1. And now I could do the derivative. Okay, the derivative is much easier now. So the derivative here is 1 over y prime. And then this will be 5 times. The derivative of ln of sine is 1 over sine x times the derivative of sine x, which is cos x, plus 9 times the derivative of ln of this is 1 over x2 plus 1 times the derivative of x2 plus 1, which is 2x, and minus the derivative of x2, which is 2x. And that's it. Derivative is done. I just need to isolate y prime. So y prime is y, which is all this, sine 5x x2 plus 1 power 9 over e to the x2 times all this, 5 cos x over sine x plus 18x over x2 plus 1 minus 2x, and that's my answer. Okay, any questions?